Hello, my name is James Lukinski, and this is Middleware for Game Audio. Audio middleware is a type of software that is used by composers, sound designers, and programmers to build the audio engine of a video game. They use the software to organize all the audio assets and link them to the core game engine. This type of software resembles a typical digital audio workstation with a suite of audio effects that could be automated to produce real-time DSP and interactive crossfading of music stems depending on the game state. The main goal of its design is to allow a composer or sound designer who may or may not have programming abilities to have more control over how, when, and where their sounds are triggered in the game environment. Middleware also provides a nonlinear environment to connect animation code with triggers of sound files. The old method of production involved the audio designer receiving a list of assets that are required for a game, composing the music or sound effects, communicating with the programmer, delivering audio files and text files delineating when and where sounds should be triggered. Then the audio engine used to be coded from scratch by the audio programmer, and every sound required their own lines of code to be triggered with proper gain levels set before they could really be tested within the game. As games became larger and more complex, this old way of production became a bottleneck and more inefficient and costly to achieve quality results. The biggest difference with third-party middleware is that the task of implementing audio into a game can now be handled by the audio designer much more efficiently. In the new model of production, most middleware software have a graphical user interface that resemble familiar DAWs like Pro Tools, Ableton Live, or Logic Pro, and as well as having an application programming interface, or API as it's known, that provides scripting capability. The API is where a user can create and edit trigger functions. The audio designer would work in this environment and deliver a finished sound setup to the programmer. Things like volume attenuation, depending on the distance from a sound source or certain game states, could be defined graphically by some form of automation curve. An audio designer and programmer would agree upon certain parameters called hooks that are used to trigger specific sound files in the code. A hook could be something like car speed, which the game engine will keep track of in miles per hour or kilometers per hour. As the value of the car speed variable increases, its function can be used to trigger different sound files of engine sounds with variant levels of intensity, much like a sampler triggers different dynamic samples depending on velocity. The value of the hook will control the timing and crossfades, as well as the selection and balance of separate low, medium, and high-speed car engine sound files. This could be triggered by simple if and else if statements. In a more complex situation, that would include layering air intake sounds, muffler sounds, wind, and the pitch of the engine sound changing simultaneously. Once the programmer ties the value of the parameters to the game's event with a script, then the car's visual speed will match its perceived audio intensity. It's common for the audio programmer to work in the API. This is a set of instructions and script-based standards that allow access to the middleware's codebase without having to delve too deeply into the main code, which in most cases is closed source and may not be accessible. Common scripting languages that are used are JavaScript or Unity script, a form of Python called BooScript, and C#. Coding in relevant script languages is something game audio designers should learn in order to edit triggers and randomize repetitive sounds in games like footsteps and gunshots to create realistic and organic sounding effects. Many of the latest versions of middleware give you the ability to mix the game live with virtual mixers and level faders, effects, and other properties like reverb, EQ, pitch shifting, panning, and delay effects. This is a major leap from the old model and resulted in much more time efficiency. Some of the most popular middleware in use today are Fmod Studio by Firelight Technologies, well known for its vast amount of built-in DSP and effortless porting to different platforms and consoles, and Waveworks Interactive Sound Engine, also known as WISE by Audio Kinetic, which is a powerful software that works on PC. It enables randomizing real-time effects and profiling of the audio's data footprint in real time. Other notable audio engines are the Tasman Audio Fabric, Microsoft's Exact, the Unreal Developers Kit, and Unity 3D's audio engine based on the Fmod structure. These are just some of the audio engines that you may need to use if you want to pursue a career in game audio. I hope this gave you some insight into the use of middleware for game audio. Thank you.